Hello everyone, welcome back. Today we will be going to do the Fibonacci series. So it is we will be doing using the method recursion. Okay, so recursion, this is a continuation of another video. In the previous video we have done the recursion but with the for the problem of factorial. Okay, so you can go and watch out that. For this also it will be starting from the scratch if you are new to this series, so even you can watch from here as well. Okay, so let's get started. Fibonacci series is basically what a series of number. How you will make it that series like simple. Don't think like a programming way. Like, what is Fibonacci? If we will just write the Fibonacci series number, what are they? So 0 1, then the number will be added. Like, so basically 0 and 1 is like the base number that first we will write, and from third number onwards we will be adding. Like 0 plus 1 is 1, so 1 plus 1 is 2, so third number is okay. At a time we will be keeping three number at a point. Okay, so 0 1 and 1, so this is like keeping 0 and 1, we will add, make the third number. Okay, now again we will take 1 1 and 2, this we will take, so 1 plus 1 is 2. Okay, then again three numbers we will take. Okay, 2 plus 1 is 3. Okay, 3 plus 2 plus 3 is 5. Okay, then 3 plus 5 is 8, then 8 plus 13 is 21. So this way we will be writing the Fibonacci series numbers. Okay, so let's go into the programming depth. I'm doing with the help of C program, keeping the same logic you can also do in Java, C++, Python, any language. The logic remains the same. Okay, so try to understand the logic and the flow that the recursion is following. Okay, how the program is going to traced, how we are going to do the dry run, how we'll get the output. So just keep the focus on the recursion part. Okay, that's the very important thing. So first we will start off with main. Okay, so it doesn't matter like if you are writing the user defined function above or below, it doesn't matter. It's just you need to add a function prototype at the top according to the C programming rule. Okay, so we will do that in a live programming another video. Okay, I'll explain you that. In this video we'll basically focus on the dry run. Okay, so first our program will start from main. Okay, here you can like int, if you are writing int then you need to return some value. If you are writing void, then this return should not be there. Okay, because void will not return anything. Okay, so int main, and I am taking like a number 10. You can take a shorter number and do the dry run, like keep the number as 5 to 6 as recommended. 5 or 6 you just keep the number and do the dry run. For more understanding purpose I have taken a larger number. Okay, now this is just a print statement that will be printed. Okay, and this is like, okay, first of all that I told, like 0 and 1, first two number will be something that we will only give. It's nothing, no calculation is required for that. So print 0 and 1, we will directly keep that. Okay, factor this percentage d 0 and 1. Hope you are getting this. Okay, this is the basic things, I'm not going to explain deeper into it. Okay, now from here you need to keep a focus. Like, this is written print Fibonacci, but this is not some kind of a print function. This is a function name, print Fibonacci. Print Fibonacci is a user defined function name that is passing a value of n minus 2. Why n minus 2? Because n is what like we are keeping n 5 or 10 or something. What is n? N is like number of series, the nth series that you want in your Fibonacci. Like if I am telling n is 5, So 0 1, 0 1, this I will count it like 1 2 3 4 5. So my Fibonacci series will be just from 3 till here, okay, only till here. Okay, if I'm keeping as 10, so this number total count should be 10. Okay, so like 1 2 3 4, we will count it till 10. So here we have already given two number. Okay, so what is the remaining number? 8. So we will be passing n minus 2. Okay, so whatever the number may be, like 5 4 anything, so it will be passed like n minus 2. 2 have we have already written, printed, and now we will be going forward with n minus 2 numbers, nth numbers. Okay, now this function will take us to this. Okay, now this is a user defined function. Okay, print Fibonacci. So print Fibonacci is a one word, don't keep a space in between. Okay, so this will make the thing go wrong. Okay, if you keep a space between it, it is not going to work. Okay, so there is no space, you can see. Okay, okay, now this will take the number n. So n minus 2, whatever the number was, 8. So this 8 will go and hit here. Okay, so initially we'll keep our n as 8. Okay, for understanding, I have written the numbers over here. Okay, see, our number was 10 initially, and then it became 8, and then minus 1 we will decrement it as we will put our number into series. Okay, so here we have come up with the number 8. Okay, so here again we see, here 0 and 1 we have printed, so the same number we are storing in n1 is 0, n2 is 1. So 0 and 1 I have covered up with n1 n2. n3 will be something like sum of n1 n2. Okay, and then I will shift my 3 numbers back. Okay, so then again my n1 will become 1. Okay, n2 will become 1, and n3 will become 2. Okay, so this way we will keep on shifting the things. Okay, so we will keep on shifting the things. Okay, so here this loop will run if n is greater than 0. So obviously my n is 8, this is obviously greater than 0, so this whole thing will run, and it will go till my n is greater than 0. Okay, the moment my n is 0, it will stop. That means I have covered all my series number, and there is no need of further numbers into the series. So this will end, and my whole program will be done. Okay, so this number, like see, first number was 0 1, we have taken as n1 n2. Now here we are going into like calculating the third number, n3. Okay, n3 will be n1 plus n2. So n3 number is stored. Okay, so n3 number is stored. Now we will shift the digits and we will print the n3, because we have found our third number, and we will now go to fourth number. Okay, so we will shift all n1 n2 n3. Okay, so n1 n2 first we need to shift, n3 we will print, and then in the second go through of this if statement, we will again calculate n3, and again we will print, and this whole loop will be carried. Okay, so n3 is calculated, n1, see, first n1 is shifted. Okay, because if we will shift n2 to n3, then n1 n2 will be lost, n2 value will be lost. Okay, so first we will shift n1. Okay, n1 is equal to n2, n2 is equal to n3. So this sequence matters a lot. You don't make mistake, it will go, everything will go wrong if you will change this series. Okay, this sequence. Okay, n1 should first take the value of n2, then n2 should take the value of n3, and this print statement is n3. Okay, n3 is retaining its value. N3 was 1 previously also, and now also after this swapping of the values, then also n3 is 1. We are not changing the value of n3. Okay, so we are printing now n3. So in the series 0 1 1 1 till here, till this third number, our series is completed. Now we will decrement it. Now coming to the next statement, print Fibonacci n minus 1. See, in my previous video also I have told, like, when you encounter a function and inside that the same function is being called, then you are getting to know that this is a recursion. Then you just start writing the things on the for the dry run part. You just start writing at the moment. See, this print function I'm getting here, so from now on I will start writing. So after my n was 8, after minus 1 it has become 7. So at this statement it is 7. So print Fibonacci 7. Now print Fibonacci 7 I have written. Okay, and this will go from top to bottom. This is like a stack. Okay, so this will go from top, we will cover, then bottom we will go down, and then we will come back. Okay, so this will be like recursion what it follows. Okay, then again print Fibonacci 7 is over. Okay, now again this whole function will be called again with the value 7. Okay, so whole number went inside. Okay, Fibonacci 7, and then okay, n1 n2 will be okay, this static. Okay, one mistake is there. See, if 7 will be called, okay, 7 will be called, then again this number will go inside 7, and again n1 n2 will be initialized with 1 and 0. Okay, and again n3 will be initialized with a null value. So this should not occur again and again. I want this to be executed just one. So write a static over here. Okay, write a static part over here. So this will make the things clear. Okay, so this should be add a static over here. This is static. Write static over here so that the things are working properly. Okay, yeah, write static over here. Okay, static int. So for static int, what is the case, like the again when 7 will go. Okay, so this will not be initialized again, because I want my n1 n2 to retain its value. Like in my previous thing, n1 I have swapped the digits. Okay, n1 was 1, n2 was 1, and n3 was 1. Okay, so I want to retain that value. I don't want to reinitialize it. I want just static int will make n1 n2 just work once. Okay, it will not work again. So add a static statement over here. Okay, so again 7 will go inside. 7 is greater than 0. Yes, so again n3 will be calculated to, okay, n3 will be calculated to 2, and then n1 n2 will be swapped. Okay, and this print the digit, and then print Fibonacci 7 minus 1, that is 6. Okay, so here you can write the n1 n2 n3 values like 0 1, then calculate 3. Okay, n3 calculate, and then swap the number, like 1 will go above, again 1 will go above, and in the second phase 2 will be calculated. Okay, so we have calculated till here, print it till here. Okay, print it till here. Now in the third rotation, 6 will go inside. Okay, this statement will not be executed. Just keep in mind this n1, n2, n3, for only for the first time it is executing. For the second time it's not executing because static is there. Okay, static is a keyword. Okay, you can search more about static, what and all it provide the feature. Okay, so here 6 number will go. 6 is greater than 0. It will calculate n3. Okay, for the 6 number, n1 is swap the number, n2 is this. Okay, n3 will be calculated 2 plus 1 3. Okay, then swiping is occurring. Okay, swiping, how it is occurring? 2 will go above. Okay, see diagonal here in this what I've written, see the diagonal, it will go above and 3 will go above. Okay, till this copying of value will occur and printing will occur. Here 3 will be printed, and then I will go for my next rotation. Okay, here I will write the print Fibonacci 6 minus 1, that is 5. Okay, in the second rotation, 5 will again go. 5 is greater than 0. It will be calculated. n3 will be n1 plus n2. So n3 was 2, 3. Now it is calculating 5. Okay, and then swapping will occur. Like 3 will be copied over here. Okay, 5 will be copied over here. Just swapping of the values will be there in n1 and n2. Okay, and n3 will again, this will be calculated at the next rotation. Okay, and then we will write print Fibonacci n minus 1, that is 5 minus 1, that is 4. Okay, so in the same way we will go till 0. Once we have reached 0, okay, again it will come up with 0 is greater than 0. So I'm not going deeper into, like, you can follow what till now we have done. You can follow that, and when we will reach 0, n is 0. Okay, so n is greater than 0, this will be false. Okay, it will not go inside this, it will directly end. So see, I have not written any base condition. In my previous factorial recursion problem, base value was there. Okay, here we are not keeping any base value. Why? Because we are just printing some values, okay, in a series form. By default nothing is returning. Okay, no base condition is there, but then also my program is ending because see, n is decreasing. First of all, it will not go till infinity because n is decreasing, and at 0, if it is less than 0 or is equal to 0, I'm not keeping any condition for that. Okay, so when this will be 0, now the value is like nothing, null. Okay, so this will be like Fibonacci 0 will be having no value, so it will go above to Fibonacci 1 with no value. And see, in my previous question, 1 was multiplication, some number was in multiplication with this, so we were just multiplying that number. Now we are not having any multiplication with this function. Okay, like 1 into print Fibonacci 1 or 2 into print Fibonacci 1, we are not having that kind of numbers. Okay, so it will just return null to everything. Okay, print Fibonacci will return 0 will return null to Fibonacci 1. Okay, this will return null to Fibonacci 2, null to Fibonacci 3, 4, 5, 6, 7, and ultimately my program, once it is coming back to 7, my program will come here, this statement, then this will return over here, and then kernel will return 0. This program will return 0 to the kernel, this one, and then my program will end. So this is like a whole flow how this Fibonacci series of recursion will be working. Okay, so practice with a different number. I would suggest don't keep n as 10. Okay, keep n as 5, some smaller number, so that you are getting how the things are working. Okay, and keep practicing. Recursion is a very important topic. It helps in a lot of problem solvings. So yeah, keep learning.